Welcome to HPC News Bytes, a weekly show about important news in the world of supercomputing, AI, and other advanced technologies.
Hi, everyone. Welcome to HPC News Bytes. Hi, Shaheen. Generative AI and the shortage of GPUs is our lead story again. AWS has launched their new P5 cloud instance. It has 8 Nvidia H100 GPUs attached to AMD Milan CPUs. It has 2 terabytes of system memory and 30 terabytes of local NVMe storage. It's connected to the outside via 3,200 gigabits per second of aggregate network bandwidth, in addition to GPU Direct RDMA to bypass the CPU if needed.
It's quite a beast, but you also need a beastly bank account to support it at something like $100 an hour on demand and probably $70 an hour spot price. Last we checked was about that. You're looking at $600,000 to $900,000 per year. So you'll definitely have to do the math, and especially if you already have in-house IT capability and on-prem as an option. Another big news was TACC, Texas Advanced Computing Center. They announced the mini Aurora. So this is really a good news for Aurora, a 4 petaflop system with 560 Intel CPU Max and 40 GPU Max chips. They've merged this with their existing 2021 system Stampede-2 to create a big new Stampede-3. Notably, this is an Omni-Path interconnect system, as it was with Stampede-2, now upgraded to Cornellis's Fabric 400 gigabits per second for 24 terabyte per second of backplane bandwidth.
You know, TACC has always been one of the largest academic HPC sites. In all, this is a 10 petaflop system with 300 terabytes of memory, 1,858 compute nodes, and 140,000 cores, along with 13 petabytes of new storage. The new edition adds 63,000 cores and high bandwidth memory for performance-intensive jobs. Speaking of memory, Shaheen, Micron announced it is sampling what the company said is the industry's first 8-high 24 gigabyte HBM3 Gen 2 memory with bandwidth greater than 1.2 terabytes per second and pin speed over 9.2 gigabits per second, which is, to quote the company, up to 50% improvement over currently shipping HBM3 solutions.
Yeah, this was designed in the US, built in Japan, and packaged in Taiwan. So this shows again the continued complexity of supply chains and the growing importance of packaging as chips go 3D with increasingly sophisticated stacking. A new word along those lines that we're going to hear often is CoWoS, for chiplet on wafer on substrate, and the glue technology that binds them. Now, back in the news was Leonardo. That's number 4 on the top 500 at Cineca in Italy. But the news here is not the system, but the actual building. They have a notion of white space, which is where the system resides, and gray space for everything else. And they've built it in 3 physical layers, the building itself. The basement has 4 independent tunnels for the cooling system. The main floor is where the machine is, and it's beautiful. And the floor above it has 4 power stations. It's really cool. You should see it.
Yeah, interesting insight, Shaheen. You know, and with more powerful, bigger, hotter, and huger supercomputers to come in the US around the world, Cineca's infrastructure strategy could be influential in the design of supercomputing centers to come.
Indeed it is. All right, that's it for this episode. Thank you, everybody. Until next time.
HPC News Bytes is a production of Orion X in association with Inside HPC. Shaheen Khan and Doug Black host the show. Every episode is featured on InsideHPC.com and posted on OrionX.net. Thank you for listening.